So, the first release of the year 2023 has been launched. On March 21st, the 11th iteration of JDK was released, following the 6th-month release schedule that started with JDK 10. In this semi annual edition of JDK, some seven significant, or we can say most talked about JAPs were included. These JAPs or Java enhancement proposals fall either in incubator or preview status. The long term support release, which will be the last release of the year, is scheduled to come in September 2023. We'll talk about that later. But first, let's explore what's there in Java 20. As we know that features in preview mode are closer to becoming standard, but still they are not permanent. They can be replaced in the next release cycle. The seven JAPs that comes up with JDK 20 can be grouped into three broad categories. The language features, which comes from Project Amber, libraries improvements from Project Panama, and improvements or updates to Java concurrency model, which falls under the Project Loom. So let's begin with the language features first. Project Amber. Project Amber had two JAPs included in JDK 20. JAP 432 record patterns, which is in its second preview, and JAP 433 pattern matching for switch, which is in its fourth preview. If we talk about JAP 432, it added three key support, or we can say three changes to the record patterns. Now we have a support for type inferencing for generic record patterns. And now there's a support for record patterns in enhanced for loop header. So inside the for each loop, now you can add your record patterns. And the support for named record patterns has been removed. That means named record patterns will no longer be supported. As per the official docs, now record patterns and type patterns can be nested to enable a powerful, declarative, and composable form of data navigation and processing. And if you remember, JEF 432 is related to JTK 19's JEF 405, which was the first preview of the record patterns. Next, we have JEF 433, which is pattern matching for switch, and it is in its fourth preview. This improvement allows an expression to be tested against a number of patterns, each with a specific action, so that complex data-oriented queries can be expressed concisely and safely. This round of preview included three changes. Exhaustive switch will now throw match exception instead of incompatible class change error. So that means an exhaustive switch, like a switch expression or a pattern switch statement, over an enum class now throws match exception if no switch label applies at runtime. Next, we have the simplification of the switch label. That is, the grammar for the switch label is simpler now. And now there is a support for type inferencing of record patterns in switch labels too. That means inference of type arguments for generic record patterns is now supported in switch expressions and statements, along with other constructs that support patterns. JEF 433 relates to JEF 427, which comes in JDK 19 and which was the third preview for the pattern matching for switch. The second category of changes is related to Project Panama, and it's about the library enhancement. And there are two JEFs included in this in the JDK 20. JEF 434, Foreign Functions and Memory API in the second incubator status, and JEF 438, Vector API. The three API changes related to JEP 44 are these, and they are included in this JEP. The first is the memory segment and memory address abstractions are unified now. That means memory address are now modeled by zero length memory segments. Next, we have the sealed memory layout hierarchy is going to enhanced to facilitate uses with pattern matching in switch expressions and statements. And memory session has been split into arena and segment scope to facilitate sharing segments across maintenance boundaries. So overall, the goals of this JEP were to provide an ease of use. It replaces the Java Native Interface JNI with a superior pure Java development model, providing performance that is comparable to existing APIs and providing different ways to operate on different kinds of foreign memory, like with native memory, persistent memory, and managed heap memory, and the capability to accommodate other platforms and foreign functions written in languages other than C, as we know, like C++ or Fortran. And most importantly, it allows programs to perform unsafe operations on foreign memory but warn users about such operations by default. JEF 434 in JDK 20 is related to JEF 424 of JDK 19, which was again the second incubator of this feature. Next, we have JEF 438, the vector API, which is in its fifth incubator status. Vector APIs, as we know, were incubated in JDK 16 through JDK 19. JDK 20 incorporates feedback from users of those releases as well as performance improvements and implementation enhancements. JEF 438, the fifth incubator for Vector API, was added later in the release process for JDK 20. So no API changes were made to the Vector API in JDK 20, and JEF 438 clarifies that Vector API will remain in incubator status until features from Project Valhalla, specifically value classes, are delivered. Now let's move on to the third set of improvements that falls under the Project Loom, and that are related to the concurrency model, or we can say an approach to deal with concurrency in Java. So there are three JEPs that were included in JDK 20 for that: JEP 429, JEP 436, and JEP 437. JEP 429 is related to scoped values, and it is in its incubator status. It is the most significant change introduced in JDK 20. This JEP introduces scoped values, which enable the sharing of immutable data within and across threads. They are preferred to thread local variables, especially when using large numbers of virtual threads. In a nutshell, scoped value provide an immutable way to share data within and across virtual threads. Next, we have JEP 436, virtual threads, and they are in its second preview. Virtual threads, as we know, were proposed as a preview feature by JEP 425 and delivered in JDK 19. This JEP proposes a second preview to allow time for more feedback and to get more experience with this feature. So virtual threads enters second preview with JEP 436. No new API changes were introduced with JEP 436. Several APIs introduced in JDK 19 were finalized in this stage, and they consist of these methods. The methods in thread, join, sleep, and thread ID. New methods in future to examine task state and result, and the change to make executor service extend auto closable. Next, we have JEP 437, which is related to the structured concurrency and which is in its second incubator status. Structured concurrency, as we are aware, was proposed by Jeff 428 in JDK 19 as an incubating API. So this JAP proposes to re-incubate the API without any changes to get more feedback and to get more experience with this feature. The only change in the re-incubated API is that a structured task scope is now updated to support the inheritance of scoped values by threads created in a task scope. This streamlines the sharing of immutable data across threads. And it is now entered into the second incubator, so it is more matured than JDK 19. So this is the official snapshot of all these 7 JAPs that we have discussed. Other small changes that were a part of JDK 20 but were not significant enough for JAPs are these. We can see that there is support for Unicode 15.0, improved control for G1 concurrent refinement threads. Now there is a support for CLDR version 42, improved API page, update to time zone data to 2022, auto-generated IDs in Java doc headings, and so on. So these are the minor yet important changes that are a part of JDK 20 release. And that's it. This was just a brief intro to JDK 20 enhancement proposals. Now the question is what's coming in Java 21, which is due for September 2023. 19th September has been decided as the release date, and which will be a long-term support release. As per the latest status, JDK 20 is in ramp down phase 1, where the overall feature set is frozen. No further JAPs will be targeted in this release. So the final release is scheduled to get available on 19th September 2023. Java 21 will have 15 features, as the previously proposed 16th feature was dropped last week. So the 15 features that made their way to final list range from previews of string templates and structured concurrency to virtual threads to key encapsulation mechanism API. And we can see that string templates, foreign function and memory API, unnamed patterns and variables, unnamed classes and instance main methods, scoped values, and structured concurrency will remain in preview stage, while vector API will get entered into its 6th incubator phase. Features like sequence collection, generational Z garbage collection, record patterns, pattern matching for switch, virtual threads, and key encapsulation mechanism API have either been completed or indicated for the final release. And we can see that there is also a proposal for the deprecation of the Windows 32-bit x86 port for removal, with the goal to remove the port in a future release. The proposal is intended to update the build system to issue an error message when an attempt is made to configure a build for Windows 32-bit x86 port. The message will be suppressible via a new configuration option. Also, the plan is to mark the port and related port specific features as deprecated for removal in relevant documentation. So the proposal notes that Windows 10, which is the last Windows operating system to operate 32-bit operation, is now reaches to the end of the life in October 2025. And there is also a proposal to prepare to disallow the dynamic loading of agents calls for issuing warnings when agents are loaded dynamically into a running JVM. These warnings are intended to prepare for a future release that disallows the dynamic loading of agents by default in order to improve integrity. So now you must be wondering why everyone is calling JDK 21 a long-term support release. There's a bit background behind this term, the long-term support release. In June 2018, Oracle and its partner in the Java ecosystem announced a change to the release cadence model for Java, which is rather than having a major release plan for every 2 to 3 years, which would often become 3 to 4 years, a new 6-month feature release train model was advocated, where every 3 years a release would be designated as a long term support release and receive quarterly security, stability, and performance updates only. So, the long term support release model allows technology providers to zero in on particular versions in the longer term support of their products. And as a long term support release, JDK 21 would get 5 years of premier support and extended support until September 2031. The current LTS release is JDK 17, which was launched in September 2021 and which Oracle intends to support through at least 2029. So, being a long term support release, Java 21 is crucial and it is going to impact our work significantly. More in detail about this release we will discuss once it will become available for general use post September 19. Other than this, you can consider visiting dev.java and insight.java to remain updated and connected with the happenings within the Java community.